The integer types are simple, fundamental data types for representing integer values, that is, whole numbers with no fractional part. The integer types include char, C-H-A-R, I pronounce it char, some people say char, int, short int, long int, and long int. These are all available in both signed and unsigned versions. The size of each type will vary depending on both the architecture and the compiler. The char type is defined as the minimum size necessary to contain a character. On most modern systems, that's 8 bits. The char type may be signed or unsigned by default. That is, on some systems it may be signed, and on other systems it may be unsigned. You cannot count on a char being one or the other. The only thing you can count on is that it will hold a character. All the other integer types are signed unless modified with the unsigned keyword. The short int is the smallest natural size of an integer for the target processor. It may be the same as int. On most modern desktop systems, it is 16 bits. The int type is the natural size of an integer for the target processor. On most modern systems, it's 32 bits. The long int type is at least the size of an int, and it's often double the size of an int. On most modern systems, it's either 32 or 64 bits. The long int is at least the size of a long int. It may be double the size of a long int. On most modern systems, it's 64 bits. For the signed types, the most significant bit is a sign bit. Unsigned types are available with the unsigned modifier. If your usage requires an integer of a specific type, the C standard int header provides types in these specific widths: 8 bits, 16 bits, 32 bits, and 64 bits. And these are available both in signed and unsigned varieties. Here I have a working copy of working.cpp from Chapter 5 of the exercise files. This system is a Mac with an Intel 64-bit processor using the LLVM Clang compiler. And so let's look at some of the sizes of the integer types. I'm going to do this like this. I'm going to say printf. Size of char is %LD bits. And I'm using the LD here because that's the long integer, and size of returns a long integer. And I'm going to use size of right here. And so that'll print out the size of a char, and I'm actually going to multiply that by 8 so we get it in bits. And when I build and run, you see it says size of char is 8 bits. So I'm going to go ahead and copy and paste this 5 times and get one more. And we'll say short int, or regular int, and then long int, and long int, and then do the same over here. And this will just tell us what sizes all of these are on this system. So now when I build and run, we see that a char is 8 bits, a short int is 16, a regular int is 32, a long int is 64, and a long int is also 64 bits. The size of operator returns the number of bytes for a given type, or the result of an expression. Here I multiply the result by 8 to give the result in bits. On a PC, we'll see some slightly different results, and we'll get to that in a moment. It's worth mentioning that due to a legacy feature from C, int is a sort of a default type. And what that means is if I take out the word int here and just leave short, that'll actually give me exactly the same result here, 16. So short is just a shorthand for short int. And it's also true of long and of long. And so if I build and run, you see all of those work exactly the same. For my part, I don't like using the shortcut. I think it's a bad idea. I suggest you always use the full type name, but you need to know that this capability is there because you will see it sometimes in existing code. So now I've done something a little bit different here in this movie. I actually also have Windows running on this same machine. I'm using Parallels, and it's Windows 8.1, and I'm running Microsoft Visual C++, Visual Studio, and I have exactly the same file open. So if I switch over to Windows, which I'm going to do right now, and you see that it's got a little dialog box here saying that the file has changed, I'll just say yes. And that's because this has exactly the same file open that is open on the Mac side of this same machine. So they're working on exactly the same file. And you see that I've got this with all of these types in it here. I'm going to press F7 on this Windows machine, and that'll build this, and then I'm going to switch to a command line where I can run it, and you see our results over here. So you notice that it's slightly different. On the Mac, long int was 64 bits, and here it's 32 bits, yet long int is still 64 bits on both machines, and regular int is still 32 bits on both machines. The only difference here is that long int is 32 bits on the PC. And so that can actually create a problem if you're trying to run the same code in both environments, and if you're counting on a particular variable being of a certain number of bits, a certain size. And so for that reason, we actually have the C standard int types, and those are available in this header called C standard int, like that. And so instead of these types here, I'm just going to change these. I'm going to say int 8t, and it looks like that. And I'll go ahead and copy and paste that. And I'm just going to take this and copy and paste it 4 times so that we can see the different sizes. So we also have 16 and 32 and 64-bit sizes of these. And I'll change them on this side also. And now I'm just going to go ahead here on this PC, and I'm going to build, and we'll look at it in our command line window, and you see that we can now be sure that we have 8, 16, 32, and 64 bits. And if I switch back, you see I have exactly the same file open on both of these. And so I'm just going to run clean so it doesn't get confused, and I'll build and run, and you see that we have exactly the same result here: 8 bits, 16 bits, 32 bits, and 64 bits. So if you really are concerned with the size of your integers, and especially if you're going to be concerned with it across platforms, then you're going to want to use the C standard int versions rather than the char int, short int, long int. Just one more quick thing we want to learn about while we're talking about integer types, and that's literal values. So I'm just going to declare a long integer here, and I'm just going to call it x, and I'm going to give it a value, and I'm going to go ahead and print it out here. And that's actually a long, so I'm going to give it an L there, and why don't I give it a semicolon? There we go. And now when I build and run, you see it says x is 42. So this 42 is actually a decimal integer. If I want to specify that it's a long integer, I can put an L after it like that. Or if I want to specify that it's a long integer, I can give it 2 L's. If I want to specify that it's unsigned, I can give it a U. And I can also, if I want to, I can specify it in octal. I can say 0223, and when I build and run that, you notice that the result is 147. That's because this is an octal number. When you use a leading 0 on a number, then C will interpret that as octal, base 8. So you have the digits available 0 through 7. If I try and put an 8 in here, it'll actually give me an error because it's an invalid digit in octal. I can specify in hexadecimal. I can say 0x93, which it also happens to be 147. And of course, in hexadecimal, you also have A, B, C, D, E, and F. So if I say 0xFF93, I get that big number. And in C++11, there is no standard for binary literals. In C++14, there is, and this particular compiler is already implementing it. I can say 0B10010011 like that, and when I build and run, you see that the value is again 147, and that's also the name of a Star Trek episode. Unfortunately, this is from a later standard, the C++14 standard, and this will not work on a Windows compiler. So if you're trying to compile this, at least today, as I'm recording this at the end of 2014, this will not work in the version 18 version of the Microsoft C++ compiler. In later versions, I expect that it will work. So C++ provides a full selection of integral types in many sizes, both signed and unsigned.